During a titration, the pH of the solution in the conical flask or beaker will change. As a base is added to an acid, for example, the pH of the solution will increase. If we actually measure and plot a graph to show how the pH changes, we get an interesting shape called a pH curve. For example, if sodium hydroxide, a strong base, is added to hydrochloric acid, a strong acid, the curve looks like this. If you track how the pH changes, there is a sudden, rapid change where the solution appears to almost go straight from acidic to alkaline. It is this rapidly changing part of the pH curve that we are really interested in with a titration. It is at this point that the solution is switching from acid to alkali. In other words, it is during this moment that all the acid molecules that were in the flask at the start have reacted with added hydroxide ions. There are no acid molecules left to react, and any more hydroxide ions being added just make the solution alkaline. The exact point at which there is no more acid left and no excess base or hydroxide ions present is called the equivalence point. At this point in the titration, there should only be salt and water present. Just enough base has been added to perfectly react with all the acid present at the start. Any extra base added after this has nothing to react with and causes the pH of the solution to rapidly change. This equivalence point will occur very suddenly in a titration. It's a bit like imagining a seesaw with the moles of acid and base on each end, with one constantly being added to. At some point, the seesaw will start to tip, and bang, it will suddenly pivot over completely. During this pivoting, however, there will be a very short moment in time where the amount of acid or base added to one end equals the amount of base or acid on the other end, and the seesaw will be level. Although you can't really see this exact moment unless you watch everything in slow motion. However, you know it happens in the middle of the seesaw tipping over. This pivoting is like the sharp line of a pH curve, and the equivalence point in a titration, the moment at which the seesaw is level and the amount of acid or base added is the same as the amount needed to completely react with the base or acid in the flask at the start, meaning none of each is left over. The exact equivalence point will be in the middle of the sharp line in a pH curve, just like the moment the seesaw was level whilst it was in the middle of tipping over. In a titration, we can't see when this is happening, and instead try and identify this point by using an indicator. When the indicator changes colour and we stop the titration, we describe it as the end point.